Hi all, I am Jitin Kuriakos, working as Assistant Professor in Department of Mechanical Engineering, Jyothi Engineering College, Cherudarthi. In this video, I am dealing with the Magnetohydrodynamic systems, particularly its two classifications. So it comes under the sixth module of Sustainable Energy Process. So what is a Magnetohydrodynamic system, or simply MHD system? It's a device or a system that can convert the thermal energy of fuel, that is the thermal energy created by burning some fuel. Directly we can convert the thermal energy into electrical energy. So its basic working conditions and its advantages and applications, all those things are actually dealt with in a previous video. So it has two types. First one is open cycle MHD and second one is closed cycle MHD. So this schematic representation is the open cycle MHD system. So in this we can see this particular area is actually the MHD system or MHD generator, magnetohydrodynamic generator. From the figure itself we can see that it's more like a diverging tunnel like structure. So its inlet is on the left side, as you can see from the figure, and to that inlet we are actually providing the burned or high temperature gases. So I will explain from the starting itself. So this is a combustor chamber. Okay, so we are supplying fuel along with air. It's actually hot air. I will explain how the air is being heated up. So we are supplying fuel and air here. So it will get combusted here, and high temperature combusted product will be taken out, and we will pass this high temperature gas through a nozzle so that its velocity will be increased, and this high velocity hot gas will be passed through this MHD generator. So the MHD generator consists of two magnets, so that it will provide a magnetic flux line which will be aligned perpendicular to the direction of flow of this hot gas, so that this hot gas, which is actually, because of its high temperature, it's a conductor. So this conductor cuts the magnetic fluxes, and thus the EMF will be generated in that gas. And we can place electrodes which can be arranged perpendicular to both the magnetic flux lines as well as the hot gas flow direction, so that we can extract the electrical energy. So the electrical energy can be extracted, and that obviously will be a DC supply, and we need an inverter to convert that into an alternating current. So we got the current. Then what happens to the exit of the MHD system? The exit gas will have sufficient amount of heat energy. Okay, that heat energy can be extracted to the fresh air which is being fed into the combustion chamber. So for that extraction we will pass the exhaust of MHD through a heat exchanger, where the inlet air taken from the atmosphere will be preheated and will be supplied to the combustion chamber. Again, still we have a sufficient amount of temperature available in the gas. So that gas that is exit from the air preheater will be supplied to the another steam generator, where the water will be supplied, and the water will absorb the remaining heat energy, and it will become steam, so that it can power an auxiliary steam turbine, which can again couple to the generators or other useful mechanical power can be used for another useful product. Okay, and the output of this steam generator will be passed through a seed recovery system. So what is this seed? It's normally potassium, liquid potassium will be, or cesium will be given as the seeding element in this particular system. So normally potassium will be given because that is a low cost seeding material. So what is the purpose of seeding? I thought initially that this hot gas is actually conductor. because at ionization temperature gases will become a conductor. But to increase the conductivity, we can add some other elements. That type of elements is called seeding elements. So here you can see the seed cycle is coming like this, and the seeding element is actually being mixed with the output of combustor before it gets high velocity. Okay, so the seeding is actually to increase the conductivity. So as the conductivity increases, the efficiency or the easiness to generate electricity will be more. So that's why we increase the conductivity. Okay, so after seed recovery, it will be again passed through a air purifier where the nitrogen, sulfur, all other things will be, the poisonous substances will be removed and will be expelled to the atmosphere. That is what an open cycle MHD is all about. Okay, so the recovered seed, that is normally in open cycle system we will use potassium, will be again fed to the combustion product. So during this cycle, a small amount of seeding element will be lost. So that quantity will be added as a makeup seed arrangement. So again, the predefined quantity of seeding element will be supplied to the combustion, and the cycle continues. So why it is open cycle? We are admitting or absorbing air from the atmosphere, and it gets combusted. It's added, seeding is added, then it passes through the MHD, then preheater, then steam generator if any, then and finally it gets exhausted to the atmosphere. So it is an open cycle system. Clear? So next one is a closed cycle MHD. In this we have again some classifications. So first type one is closed cycle MHD with the seeded element in inert gas. Okay, so here the working fluid will be inert gas. In the previous case, working fluid was air. Okay, here air plus fuel combustion. Okay, the combustion product was the working fluid. Here it is inert gas. Okay, and the second category is inert gas itself, but the seeding, instead of seeding elements, we will add some liquid matter. The third classification is a fast breeder reactor coupled MHD system. So you know what is a fast breeder reactor? It's a nuclear reactor. So a nuclear reactor coupled to MHD system. These are the types. So the first two types have a similar construction. So here this is the MHD. So as the directions you can see here, the hot gas either seeded with the cesium or maybe added with the liquid metal will be supplied to the MHD system, and output will be again compressed and supplied to the heat exchanger where it gets heated up. And again, so this inert gas is passing through this closed cycle. Okay, then how this inert gas is being heated up? For that, we are absorbing air from atmosphere, and with the help of fuel, we combust this air. Okay, and we combust the fuel. Okay, and that hot combustion product will be passed through a heat exchanger, which will transfer the heat of combustion products into the argon working fluid here, or the inert gas working fluid here, and the exhaust of the primary heat exchanger will be expelled to the atmosphere after purification, or maybe for some preheater arrangement for other cases. Okay, and at the output of MHD system, as in the previous case, I said here also a large quantity of heat will be available. So we can place a heat exchanger so that an additional feed water supply can be supplied through this heat exchanger, which can be converted as steam and can be powered a steam turbine. You can power a steam turbine. So maximum amount of heat utilization is possible. So here a steam cycle is there. Okay, closed cycle steam cycle is there. Then a closed inert gas supply or cycle is there, and an open cycle flow of combustion air products. Okay, so here for the cesium element can be used for seeding of argon element, because cesium offers a maximum efficiency, but it has a slightly more costlier. Okay, so instead of cesium we can add liquid metal for increasing the conductivity. So the last category is fast breeder reactor coupled MHD. Okay, so here this is the fast breeder. So in nuclear reactor we are actually generating heat. So a liquid potassium or liquid metal normally will be used to extract this heat energy. So here it is shown as liquid potassium. So the high temperature liquid potassium will be drawn from the reactor, and its vapors will be separated, and the liquid hot potassium will be passed through MHD chamber, and the output of MHD will be again passed through another heat exchanger for generating steam. After that it will be again pumped back to the reactor. Okay, so in the separator the vaporized potassium will be condensed and fed back to the reactor. Okay, so here also as in the previous cases, the excess energy or the waste heat can be utilized for powering a steam turbine. So this is what a closed cycle MHD is. Be clear about this. Thank you.